Good morning, everybody. Today we are going to solve October-November 2016 1-2 paper. It's an MCQ paper, and the syllabus we are studying is Physics 5054. Okay, let's start. So you can see question number 1 is on your screen. A length of copper wire is labeled length 30 meter and diameter 0.50 millimeter. Which instruments are most suitable to measure accurately the length and the diameter of the wire? Because the length is 30 meter, so we will use a tape, and because the diameter of wires is always measured with the micrometer. So the choice is D for question number 1. The choice is D. Okay, on your screen we have question number 2. A skydiver falls from rest through the air and reaches terminal velocity. What is the acceleration of the skydiver during his fall? When he jumps, there is no air resistance, only the weight is acting, which is acting downward. There is no opposite force. So its acceleration will be the acceleration of the free fall, that's 10 meter per second square. But as he falls, the air resistance starts increasing and the resultant force starts decreasing, and the acceleration value also starts decreasing. On the terminal velocity, the upward air resistance and the downward weight, they become equal to each other, and the acceleration becomes 0. So when the parachutist will jump, his skydiver will jump, his acceleration will at the first will be 10 meter per second square, and gradually it will decrease, and finally it will become 0 meter per second square. So for question number 2, D is the choice. Question number 3, two aluminum spheres P and Q of masses 0.50 kg and 1 kg respectively are released at the same time from the same height. Why do they have the same acceleration? The reason is the force which is acting on the P and on the Q are different. We call that force weight, which pulls them towards the earth. The force which will be acting on the P and the force which will be acting on the Q, the force which will be acting on the Q will be 2 times larger than the force which is acting on the P. The weight of the Q will be 2 times larger than the weight of the P, because the mass of the Q is twice the mass of the P. So the reason is that the force on the Q is double the force on the P. So C is the choice. Okay, so we are moving to the next question. He says that on your screen you can see the question number 4. The graph shows a distance time graph for a car traveling in a straight line. In which region is the car decelerating? So the slope of this graph is a distance time graph. The slope of this graph is basically showing you the speed of the object. And when the slope is increasing, the slope is going upward and it's curving upward. Its gradient is gradually increasing. There the speed is increasing. It means that the body is accelerating. And when the slope of the distance time graph starts decreasing, and that means the slope is decreasing, that means the speed is decreasing, that means the body is decelerating. So if you look at the graph carefully, you will see in the region C, the slope has started decreasing. So region C is where the object is basically decelerating. So for question number 4, in which region the car is decelerating? C. C is the option. I hope you understand. Question number on your screen we have question number 5. A force of 20 Newton acts on an object of mass 5 kg in the forward direction. A second force also acts on the object. The forward acceleration of the object is 3 meter per second square. You applied a force of 20 Newton in the forward direction, and the body is accelerating in the forward direction with the acceleration of 3 meter per second square. So it means, and what is the size of the direction of the second force? And another force was acting on it, and due to the first and the second force, some kind of resultant force is produced, and that resultant force causes the acceleration. So let us calculate first of all that resultant force. We will use the Newton's second law of motion. F is equals to ma. The mass of the body is given. The acceleration is also given. So we can calculate what is the resultant force. And once I know the resultant force, then resultant force is we will calculate, and then we will be able to tell the resultant force, the second force is in the same direction or it is in the opposite direction. Let me show you the calculation. I have done that calculation. Okay, on your screen, I hope you are able to see. Let me increase its size. Okay, so let me go to the page. Yeah, this is here. So first of all, F is equals to ma. Five is the mass, 3 is the acceleration. So the 15 Newton is the resultant force. So resultant force is equals to because the resultant force is less than the applied force. It means that the second force which was applied, that should be opposite, because the resultant force is less than the applied force. Applied force is 20 Newton. The resultant force is 15 Newton. It means the second force which he was talking in the question, that resultant force is opposite to the applied force. So resultant force can be F1 minus F2. Resultant force is 15, F1 is 20, and minus F2, take F2 to the other side, bring this F1 15 to this side, 20 minus, so 5 Newton. So this 5 Newton force is the F2 force, second force, and it is acting opposite to the forward force. So the choice is A in your question. If you look at there, so the size of the force is 5 Newton and direction will be backwards. So choice is, for question number 5, the choice is A. Okay, on your screen right now, we have question number 6, a very famous question, that when you move in a circle, what is the direction of the resultant force? We have told you many times that whenever you move in a circle, a resultant force is always acting on you, and the direction of that resultant force is always towards the center of that circle. So here, because this car is moving in this circular path, so the arrow which is pointing towards the center of this circular path is D. For question number 6, the option is D. I hope you understand. We call it centripetal force. Okay. On your screen, let me reduce its size. Yeah. Okay. On your screen, we have question number 7. A block is hung on a spring balance. The marker inside the balance is pulled down by the block. What can the position of the marker be used to determine? You see, this Newton meter can be calibrated to measure the weight. It can also be calibrated to measure the mass also. If it is being used to measure the mass, the unit of the mass must be kg. If it is being used to measure the weight, the unit must be newtons. So look at the options. The options which he gave is the mass of the block in kg. That is true. The mass of the block is in Newton. The mass of the block is not in Newton. The moment caused by the block in Newton meter, this is not used to measure the moment. The weight of the block in kg, the unit of the weight is telling you is wrong. So A, for question number 7, A is the right option. The mass of the block in kg. Okay, on your screen right now, we have question number 8 is on your screen. You can see the density of the gold is 19 gram per cubic centimeter. A gold coin is 2 millimeter thick. Each face of the coin has an area of 4.5 centimeter square. What is the mass of the coin? You know, the cross-sectional area of the coin is given, that is 4.5 centimeter square. The thickness is 2 millimeter. The units are not consistent with each other. So we can convert the 2 millimeter into centimeter. How you convert it? You divide 2 millimeter with 10 and it will be converted into centimeter. Then you can use the formula that the volume of the coin is equal to cross-sectional area multiplied thickness. Once you get the volume of the coin and the density of the coin is also given, you can see, you see the formula for the density is mass divided by volume. And if you want to find out the mass, the formula will become density multiply volume. And you just multiply the density, which is gram per cubic centimeter, and multiply it with the volume, you will get the mass. Let me show you its calculations. I have done these calculations. You see here on your screen, I think you are able to see. Yeah. Volume is cross-sectional area multiplied thickness 4.5 multiplied 2 divided by 10. I divided by 10 to convert the millimeters into centimeters. You will get the answer 0.9 cubic centimeter. The density is mass divided by volume. So mass is density multiplied volume 19, which was the density, multiply 0.9, which was the volume, and you get the answer 17.1 gram. So the mass is 17 gram, which is B option. Okay, the question number 8, the option is B. Okay, on your screen right now, we have question number 9. A man with an open parachute is falling to earth at constant speed. The following forces are acting. P is the upward force of the parachute on the man, the upward force. Q is the upward force of the man on the earth. The R is the downward force of the earth on the parachute. S is the downward force of the man on the parachute. Which two forces are Newton's third law pair? Newton's third law pair is always those two forces which are acting on the different objects equal in magnitude, opposite in direction. For example, if the parachute is acting is if the parachute is applying force on man, the man should be applying the force on the parachute. This pair is given here. You see the P, the upward force of the parachute on the man, and S is the downward force of the man on the parachute. So P and S is a Newton's pair. So question number 9, C is the option. Okay, on your screen right now, you can see we have question number 10. Two forces X and Y act on an object and produce a resultant force. The scale diagram represents the sizes and the direction of the forces X and Y. Force Z balances the resultant force due to X and Y and keeps the object stationary. Which arrow represents the force Z? Remember, it's a tricky question. You know, he's not asking for the resultant force. He's asking for a third force Z, which balances their resultant. Okay, so if you want to find out the resultant of these two forces, force X and force Y, what you will do, you will complete the parallelogram. Okay, when you complete the parallelogram, the resultant will be the point where the tails of these two are joined. You join this point with the opposite corner of the parallelogram. That will be their resultant. Your arrow will be in this direction. That will be the resultant. But his question is not about the resultant. His question is about another force Z, which will balance this resultant force. To a force which will be able to balance this resultant force will have the same magnitude, but its arrow will be in the opposite direction. So C is the choice. It's a little tricky question. It has is trying to confuse you. Okay, on our screen right now we have question number 11. Three objects P, Q, and R have different masses and different speeds as shown in the table. What is the order of the increasing kinetic energy smallest first of the objects? So he wants us to arrange them in the increasing order of kinetic energy. So first of all, we need to calculate the kinetic energy. The formula for the kinetic energy, you know, is 1 by 2 mv square, half mv square. In the table here, the mass of the P is given, the speed is given, the mass of Q is given, the speed of Q is given, the mass of R is given, the mass of the speed of R is also given. So we will apply the formula and calculate all their kinetic energy, and then we will arrange them. I have already solved it. On your screen, I hope you are able to see. So kinetic energy of the P, apply the formula, put the values, you get 4.5 joules. Kinetic energy of Q, apply the formula, put the values, get the answer 4 joules. Kinetic energy of R, apply the formula, put the values, get the answer 2.5 joules. So you see clearly that the R has the lowest kinetic energy, Q has the medium kinetic energy, and the P has the largest kinetic energy. So the the order should be R, Q, P. So that's a D choice. I hope you have understood this. So it's a D choice. For 11, D choice. On your screen, you can see question number 12. Which power stations all rely on renewable sources of energy? It's a simple question. B. Hydroelectric power. Hydroelectric is renewable. Solar is renewable. Wind power station is renewable. So B is the choice. They all are renewable sources of energy. For question number 12, B is the choice. Question number 13 is on your screen. Which force does no work? No work is done when you apply force and the body don't move. Another situation in which the work is not done by the force, if you apply the force and the body moves perpendicular to the force, especially when you move in a circular path. Remember, this is when you move in a circular path, what happens? You check that object at any instant. The resultant force will be always towards the center of that circle. So, for example, a body is moving in a circle and the body is moving in a circle and you checked it at any instant. What will happen? The body will be having a resultant force and its direction will be toward the center of the circle. But if you check what is the direction of the motion of the body at that instant, that will be always in the direction of the tangent to that circle at that point. So tangent and the radius, they are perpendicular to each other. So, and I have told you that if you apply force and the body moves perpendicular to the direction of the force, the work done will be 0. Okay, so C is the choice, the force that causes a satellite to move in a circular orbit. Because the force which is moving the satellite around the Earth is towards the center of the Earth, but the satellite is moving in the tangential direction. So that's why the angle between the force and the motion is 90 degrees. That's why the work done is 0. So C is the choice. Question number 13. C is the choice. On your screen, you can see question number 14. He says a workman rolls a barrel of weight 2000 Newton up a plank of length 2 meter and onto a lorry. The back of the lorry is 0.80 meter above the horizontal surface of the road. What is the work done on the barrel against gravity? You know, work done has many formulas. Work done can be force into distance. Work done can be change in the potential energy. Work done can be change in the kinetic energy. So work done here, because you have moved the barrel to a certain vertical height, which is 0.80 meter, we can calculate the work done with the formula change in the potential energy. So how much is the change in the potential energy? That is equal to mgh, or weight into height. We know the weight of the barrel. We know how much vertical height this barrel has gained. So apply the formula potential energy is equal to weight into height, and you will be able to calculate the work done. Right now on your screen, you can see this work done is equals to change in the potential energy equals to mgh equals to weight into height equals to 2000 multiplied 0.8 equals to 1600 joules. So B is the choice. So B is the choice, 1600 joules. I hope you have understood how we have done this. Now on your screen, we have question number 15. An electric motor is used to operate a lift or elevator. The motor does 140,000 joules of work in 70 seconds. What is the output power of the motor? You know, the power is work done divided by time, or energy divided by time. And I have done this here. You see on your screen, power is equals to work divided by time. The work done is 140,000 joules divided with 70 seconds, and the answer is 2000 watt. 2000 watt is 2 kilowatt. So the choice is C, 2 kilowatt. The choice is C, 2 kilowatt. For question number 15, the choice is C. I hope you have understood this numerical. Question number 16 on your screen, which expression gives the efficiency of an AC generator? The generator's efficiency of generator or efficiency of anything is, especially for generator, because its output is electric energy. So it should be electric energy output divided by total energy input. For question number 16, A is the option. Question number 17 on your screen, he says The pressure of the gas supply in the laboratory is measured using a manometer, which distance gives the pressure of the gas above the atmospheric pressure. It means what is the difference of the pressure of the gas and the atmosphere. That pressure difference is always measured by the difference of levels in the both limbs of the mercury, of the manometer, sorry. What we do, we take the difference of level of mercury in both the limbs of the manometer. So if on your screen you can see, here are the two limbs of the manometer. So the difference between the mercury levels in both the limbs is represented with D. So that D tells us that how much the gas pressure is more than the atmospheric pressure. For question number 17, the option is D. Okay, on your screen right now we have a gas, question number 18, a gas expands slowly and its temperature remains constant. What happens to the gas molecules? A gas expands slowly, the volume is increasing, and the temperature is not changing. The speed will not change. The temperature is not changing, the speed will not change. But they are expanding, so the intermolecular spaces will increase. They move further apart and their average speed remains unchanged. The C is the option. Question number 18, the C is the right option. They move further apart because the volume is increasing, but their average speed remains unchanged because their temperature is not changing. You know, the temperature depends upon the average kinetic energy, and kinetic energy depends upon the speed of the molecules. If the temperature is unchanged, it means the kinetic energy is unchanged, it means the speed is unchanged. So C is the option for question number 18. Question number 19 is on your screen. A piece of paper torn out of an exercise book is shown, and it says, and some of the particles at the surface gain so much kinetic energy that they break free and take the energy away with them. Which process is being described? It's clearly, he's talking about evaporation. In the evaporation, the particles which have the higher kinetic energy, they leave the surface of the liquid and leaving behind less energetic molecules. He's talking about evaporation. So question number 19, the option is C. Next question is on your screen. Question number 20, a sample of liquid at 100 degrees centigrade is allowed to cool to a room temperature of 20 degrees centigrade. The diagram shows how the temperature changes with time during the cooling process, at which time does the sample becomes completely solid. You know, this is a liquid, and you have its temperature is 100 and you let it cool. So it's a cooling curve. On x-axis, the time is represented. On the y-axis, the temperature is represented. And as the time passes by, the temperature is dropping. And you can see here, it was liquid, very hot liquid. And here you see, between the A and A, B, and C, the cooling curve has become flat. The cooling curve becomes flat when the state is changing. So here, the liquid has started converting into solid. And after point C, the temperature again started falling. And we know that during the process of solidification for a pure substance, during the process of solidification, the temperature will not change. The temperature will start changing once again or start dropping once again once it has completely converted into solid. He says at which point it is completely solidified. So C is the option for question number 20. C is the option. At what time does the sample become completely solid? At point C. Okay, on your screen right now, we have question number 21. 1 kilogram of water needs more thermal energy to raise its temperature by 1 degree centigrade than 1 kilogram of copper. The reason is that if you want to raise the temperature of the copper, you need very little amount of energy. But when you want to raise the temperature of 1 kg of the water, you need a lot of energy comparatively to the copper. The reason is that the water has higher specific heat capacity, copper has lower specific heat capacity as compared to water. So the reason was the copper has a lower specific heat capacity than the water. So question number 21, B is the option. On your screen, you can see we have question number 22. The thermal energy produced by an electric heater in 3 minutes is used to melt wax. The wax is initially at its melting point of 60 degrees centigrade. The specific latent heat of the wax is 220 joules per gram. The heater supplies 7700 joules of thermal energy to the wax. How much wax melts? You know, he's talking about melting at the melting point. So the heat which is involved, we call it the latent, specific latent heat is involved. The formula is heat is equals to ml. Heat is equals to ml. Heat is given, and you know, on your screen you can see I'm trying to show you the calculation. Heat is equal to ml. The amount of heat provided is given 7700 joules. The mass of that wax which will be melted is our question, and the latent, specific latent heat is also given 220. So when I make the m alone, 7700 divided by 220 equals to 35 grams. So 35 grams of that thing will be melted. 35 grams. So D is the option for question number 22. D is the option. Question number 23 is right now on your screen. What makes a clinical thermometer suitable for measuring small changes in body temperature? The instrument which can measure small changes in the temperature, we call that instrument more sensitive. And how you can make a thing more sensitive, how you can make a thermometer more sensitive? There are 2-3 famous methods in our syllabus. One is to narrow the bore of the capillary in which the mercury will be moving. The other one is the amount of mercury in the bulb should be larger. So which one? Reason the amount of liquid in the bulb is small, that's wrong. It will make it insensitive. The bore of the capillary tube is narrow, that's right. The capillary tube is long, that's wrong. The glass bulb has a thin wall, that's wrong. The bore of the capillary tube is narrow. That is the thing which will make it more sensitive and make it more suitable for measuring small changes in the temperature. So question number 23, B is the option. Question number 24 is on your screen. In which state of matter does convection occur? Convections occur in gases and in liquids only. So B is the option. Question number 24, B is the option. Question number 25 is on your screen. Which statement about waves is correct? All electromagnetic waves are transverse. That's very correct. All electromagnetic waves are transverse wave. Okay, remember this fact. So A is the option for question number 25. Rest of the things are not correct. On your screen, we have question number 26. The diagram shows the surface of water as a wave passes across a ripple tank. Which length represents the amplitude and the wavelength of the wave? Amplitude is how high you go from the mean position or how low you went from the mean position. If you look at the diagram, this Q is representing the amplitude. And the wavelength is the horizontal distance between the 2 points, 2 adjacent points who are in the same phase. This P is the wavelength. So A is the choice. Question number 26, A is the choice. Question number 27 is on your screen. Let me reduce its size. Yes. A lens is used to produce a magnified image as shown in the scale diagram. What is the linear magnification produced by the lens? Okay, so it's a scaled diagram. You can measure with the help of a scale from this lens, from this diagram, sorry. And the question is, what is the linear magnification? For linear magnification, we have two formulas. One formula is linear magnification is equals to height of the image divided by height of the object. So what you can do, because you will have a hard copy of the paper in front of you, take a scale and measure what is the height of this image. Measure what is the height of this image and divide it with the height of the object. Measure the height of the object also. Height of the image divided by height of the object, you get the linear magnification. And other method is you measure what is the distance of the image from the lens, the optical center of the lens. Measure the distance of the image from the optical center of the lens and divide it with the distance of the object from the optical center of the lens. Okay. In this way, you can also find out the linear magnification. If you will actually measure on a paper with the help of a scale, if then you will measure the height of the image and you will divide it with the height of the object, the answer will be 3. So the linear magnification is 3. So B is the choice for this question. This is a question in which the my instrument is involved. You have to actually do the measurement and then you have to apply the formula. I hope it's clear that how you will measure, what you will measure, and how you will apply the formula. What is the formula? How you apply it? It's easy. Question number 28 is on your screen. A girl is long-sighted. A girl is long-sighted. Which statement is correct? She says she sees close objects less clearly than a person with normal vision. That is right. That's perfect answer. Long-sighted people can see the distant objects clearly, but they are not able to see close objects. So she sees close objects less clearly than a person with normal vision. That's true. This is the long-sighted. So question number 28A is the option. Question number 29. Sound travels at different speeds in solid, liquids, and gases. Which list shows these states of matter in order of increasing speed of sound lowest to the fastest? Remember this thing. It's a fact that the sound travels slowest in the gases. The sound travels faster in the liquid, and the sound travels fastest in the solid. So A is the option. Question number 29. A is the option. Okay, on your screen right now we have question 30. This is 30 question. Question number 30. A man stands between two tall buildings P and Q. The diagram is not drawn to scale. He is 50 meters from the P and 200 meters from the Q. He fires a gun and the first two echoes he hears are 1 second apart. What is the speed of the sound calculated from this observation? Try to understand this one. This is a little bit tricky question. So when this man fires the gun, so the sound waves are produced. One sound wave will move towards the building P, and the one sound wave will be moving towards the building Q. Because when you fire, the sound waves are produced and they move in all directions. Okay. So we are taking two sound waves, one which was going in the direction of the P, the other which was going in the direction of the building Q. The sound wave which went towards the building P, it will travel 50 meters and it will be reflected from the building P and it will again travel 50 meters. So he will hear the echo, the first echo. So this first echo, the sound has traveled 100 meters. 50 going, 50 coming back. The other sound wave which went towards the building Q, it will go to the building Q, 200 meters, and it will be reflected from the building Q and it will come back to the man, again covering 200 meters. So and he will hear the second echo. So the total distance traveled by this sound is 400 total, 200 going, 200 coming back. The difference between the distance traveled by the first echo and the distance traveled by the second echo, the sound waves of the second echo, 400 minus 100, 300. And in the question, he says that the time lapse between the two echoes is 1 second. So the distance travel difference is 300 meters. The time difference is 1 second. So what you do, speed is equal to distance divided by time. 300 meters divided by 1 second. And the answer will be 300 meters per second. So the choice will be B. Let me show you. I have done this work also. Let me show you. Okay. On your screen, I hope you are able to see. The first echo travels 50 plus 50, 100 meters. The second echo travels 200 plus 200, 400 meters. The difference of distance between the distance traveled by both the sound waves of the echo first and the second echo is 400 minus 100, 300 meters. And the time difference between both the echoes is 1 second. So the speed is 300 meters divided by 50. 1 second equals to 300 meters per second. So the choice is B. I hope you understand this. Okay, so the choice is B, 300 meters per second for question number 30. So we are moving to the next question, question number 31. Delicate instruments are often placed in a box to screen them from stray magnetic fields. What is the material used for the box and why is it chosen? It's a famous question. For screening, we always use the soft iron because it's a magnetic material. It will not let the magnetic lines go inside that box. So D is the choice. Soft iron is used because it's a magnet. It is a magnetic material. Question number 31. D is the choice. Okay, on your screen you can see question number 32. A positively charged metal sphere is placed midway between two previously uncharged metal rods, one of which is connected to Earth. Which diagram shows the charges on the rod? Okay, you see, when you will put a positive charge in the center, what will happen that both the rods, because it's positive, on this end the negative charge should appear because of this positive. On this end a negative charge should appear because of this positive charge. So on the other end, on the left side of this rod, a positive rod should appear, and on this side also a positive rod, a positive charge should appear, but you have Earth, you have connected it with Earth. So this positive, the electrons will come onto this and it will neutralize it. Okay, so the B is the right figure. So for question number 32, B is the right option. Question number 33. An ammeter and a voltmeter are connected into the circuit shown when determining the power produced by a heater. An ammeter and a voltmeter are connected to into a circuit shown when determining the power produced by a heater. For power, the power formula is IV. IV. I stands for the current. We use it, and V stands for the voltage. Current can be measured with the help of the ammeter, and the voltage can be measured with the help of a voltmeter. And ammeter, whenever you connect the ammeter, that ammeter must be connected in series, and the voltmeter should be connected in parallel to that appliance. So for question number 33, the option is C. The ammeter should be connected in series, and the voltmeter should be connected in parallel. Okay, the question number 34. He says resistors of different resistances are connected to a power supply in either a parallel circuit or a series circuit. Which statement is correct? Whenever you connect the resistors in parallel to a EMF source or power supply, so what will happen? The current might be different in the different resistors. But when you connect the resistors in series with each other, there is a single loop. There is no other path for the current, so the current flowing through all of them is same. So B is the choice. The current is the same in all resistors connected in series. Question number 34. B is the choice. He says the headlamp. Question number 35. The headlamp circuit in a car includes a 7 ampere fuse. What is the purpose of that? The purpose of the fuse is that if the amount of current coming from the supply exceeds then the rating of the fuse, what will happen? The wire in the fuse will overheat and it will melt, and it will cut the supply of the current to the appliance, and the appliance will be safe. It will be safe. So it protects the wiring from overheating. Yes, that's the choice. The question number 35, C is the choice. It protects your appliances or wiring from overheating. From a surge of current, the surge of current can overheat, and so the fuse will help your appliances to be safe from overheating or a surge of current. A current carrying wire lies between the north poles of the magnets as shown. This is the left hand rule. The left hand, you stretch the fingers of your left hand. You know, the thumb, index finger, and the middle finger. FMC. FMC. Force, magnetic field, and current. The current is going downward. The magnetic field is from north to south. My thumb is pointing out of the screen, out of the plane of the paper. So the force applied on this wire will be out of the plane of the paper. For question number 36, B is the option. By applying left hand rule, we got the answer. Okay. So here we have a question. Question number 37 is on the screen. A magnet moves up and down above a coil of wire. The bottom of the magnet moves up and down between P and R. Where is the bottom of the magnet when there is no induced electromagnetic force in the coil? The reason is, when this magnet will be moving, the EMF will be produced. EMF will be induced whenever this magnet is moving. But whenever this magnet becomes stationary, the EMF induced is zero. EMF is only induced in the coil when the magnet is moving. So because the magnet is vibrating, the magnet is attached with the spring and it is vibrating, moving up and down. So during its motion, when it reaches the point R, it stops and goes back. And when its bottom reaches P, it stops and comes down again. So it's vibrating between the two extreme position P and R. At point R, for a moment it stops, and at point P, for a moment it stops. So when it stops, there is no EMF. Okay. So the choice is for question number 37. The choice is B at P and R because the magnet stops for a moment at P and R. When the bottom of the magnet is at P or when the bottom of the magnet is at R, it stops for a moment because it is performing a up and down vibratory motion. So the choice is B. Now the question number 38 is on your screen. Okay. A resistor of constant resistance and a thermistor are connected in series with a battery. A voltmeter is connected in parallel with the resistor. The temperature falls. What is the correct changes? When the temperature will fall, you see, when the temperature will fall, the thermistor's resistance will increase. When the temperature will drop, the resistance of thermistor will increase. So it will start consuming more voltage. When it will consume more voltage, the voltage for this resistor will drop. The reading on this voltmeter will also drop because it is measuring the voltage drop across that resistor. So when the temperature drops, the resistance of the thermistor increases and the voltage drop across the resistor or the reading on the voltmeter, because the voltmeter is connected across that resistor, that will decrease and the resistance of the thermistor will increase. So the choice is C for question number 38. The choice is for question number 38, the choice is C. I hope you understand it. Question number 39. A freshly made sample of radioactive material gives a count rate of 8,000 counts per minute. After 20 days, it gives a count rate of 500 counts per minute. What is the half-life of the material? Okay. So originally there were 8,000 counts. The rate of the radiation was 8,000 counts per minute. So when one half-life has passed by, from 800 it will have 8,000, it will have 4,000. Again, another half-life passes 4,000 to 2,000. Another half-life passes from 2,000 to 1,000. Another half-life passes from 1,000 to 500. So you have to check how many half-lives have passed. He says total 20 days have passed. Okay. So let me show. I have done this on a paper. So you started with 8,000. After one half-life, it would have become 4,000. Another half-life passes, it become 2,000. Another half-life passes by and it becomes 1,000. Another half-life passes by and it becomes 500. So count how many half-lives have passed. 1, 2, 3, 4. So 4 half-lives have gone by. So total days, total time given 20 days. So it means there are 4 half-lives in 20 days. So 20 divided by 4, so 5 days. So one half-life is of 5 days. I hope you understand. So B is the choice. Question number 39, B is the choice. Question number 40 is on your screen. Let me increase its size. And right now, a nucleus of uranium-292-238 decays to thorium and emitting an alpha particle. What is the resulting thorium nucleus? Alpha decay has taken place. Whenever an alpha decay takes place. The daughter nucleus will have 2 less protons than the parent nucleus, and its mass number will be decreased by 4. From 92, if you decrease 2, it will become 90, and from 238, if you decrease 4, it will become 234. So A is the choice. Let me show you my paperwork also. I hope you are able to see this. Question number 40, A choice. Uranium 292 238, and the thorium is produced, and an alpha particle is given. Alpha particle is 2 4. So the proton number should decrease by 2. From 92 it will become 90, and the mass number should decrease by 4. From 238 it should become 34. So the choice is A. I hope you have understood it, and today's work is the paper is completed. This was paper 2000, October November 2016, and 1-2 paper. I hope you are able to understand, and the calculations which I have done here, please, when you try, always do them on a register. Actually do use a calculator and do the calculation for yourself. Then you will be able to understand the whole concept. So thank you very much. Have a good day, and stay at home and